Okay, everybody say hi, Kelsey. Hi, Kelsey. All right, Kelsey, I'm recording this, and we're online with Ellie and TJ as well, so hopefully this is recording the way that it's supposed to. Ellie and TJ, can you still see my screen?
Yeah.
Okay, perfect. All right, 3-6, inverse functions. I went ahead and wrote the assignment at the top of the page 212. I'll just take that. Do you guys all have a note sheet for this? Yeah? Okay, inverse functions. Inverse functions are functions that undo one another. So I'm going to put that here. Functions that undo each other. Okay, like y equals x squared is the inverse of what function? What undoes x squared? The square root, right? Those two things undo one another, okay? Same thing with x cubed and the cubic root. Those things undo one another, okay? So examples of that, all right? Now, graphs of inverse functions. If you graph two functions that are inverses of each other, they very beautifully are reflected across the dotted line y equals x, okay? So for example, y equals x squared is this parabola here, okay? And if I look at the square root of x, do you guys remember what the graph of the square root of x looks like?
Isn't it?
It starts here and it goes on forever. Now, those two aren't technically reflections of each other, but let me show you this. If I do plus and minus the square root of x, plus and minus, he goes down this direction as well, right? So now do you see a parabola that's up and sideways? Yeah. Now those two things are reflected across this dotted line here, okay? And that's how he looks, okay? So technically, the square root is not the inverse of x squared. It's positive and negative square root because we put the square root in there. Does that make sense? That's why the plus and minus is important, okay? So positive square root is this top part here. Negative square root is the bottom part there. And those two things are reflections across that magical dotted line if we graph them. Yeah? Good? Okay, have we talked about this before in Algebra 2? Do you remember kind of this? No? Yes? Allie does? Okay. All right, so graphing an inverse relation. The graph of the function f is shown. Graph the inverse and describe the relationship between the function and its inverse. So I already gave you a clue to this one. This is the graph of y equals x squared, right? If I take 1 and I square it, it becomes 1. So I plug in 1, I get 1 to pop out. 2 squared is 4. 3 squared is 9, yeah? Negative 1 squared is 1. Negative 2 squared is 4. Negative 3 squared is 9. That's where they get those points from for that parabola, okay? Now, the magical thing is, okay, when we graph his inverse, okay, all we do is we take these coordinates and we flip them around, okay? So instead of plotting the point negative 3, 9, it's going to be 9, negative 3. So these are going by 4. So 4, 8, 9 is going to be right here, and negative 3 is right there. So there's 9, negative 3, okay? 4, negative 2 is the one that I'm going to plot. So 4, negative 2 is right there. Then I have 1, negative 1. 1, negative 1 is that point right there. Do you guys see where these points are living? Kind of. The scale is kind of hard because they're going by 2's. Okay? So I'm just taking these coordinate points and I'm flipping them around. That's what inverses do. They invert the coordinate points x and y. Okay? Now this point 1, 1, what happens if I flip 1, 1 around? 1, 1. Now there is a point at 0, 0. 0, 0 just stays at 0, 0 as well, right? 2, 4 switches to 4, 2. 3, 9 switches to 9, 3. And he has a parabola that's on his side, just like we just got done saying. Okay? And again, there's that magical dotted line. What's the equation of that dotted line again? What's this dotted line called? Y equals x. Okay? Y equals x is just that linear function, that dotted line. And he has flipped over top of that dotted line. Okay? Does that make sense? Yeah? Okay? All right. So you're just taking each one of those coordinate points and you're flipping them around, and that's what your inverse will look like if you graph them. Okay? Now, suppose that we are not starting with the graph and that we can just flip the points around, because that would be convenient, right? Suppose we're starting with an equation like f of x equals 3x minus 2. How do I invert that? Or how do I find the inverse of that equation? Okay? There are 4 steps. And you guys probably remember these 4 steps. 4 steps to finding the inverse. You take the f of x, or whatever it's called, and you change it to be y. You guys remember this? Take f of x and you switch it to y. Then you take y and x and you flip the x and the y around. So y becomes x becomes y. Okay? Then step number 3, remember step number 3?
No.
After you have x and y flipped around, you solve the equation for y. Okay, so then I get the y by itself, and that like undoes everything in the function because it switches it around so that the other variable is solved for. And then the last thing you do is you take the y and you switch it to f inverse of x. It looks like f to the first power x, or f, whatever that thing is. What is this thing? Apostrophe. There you go. I couldn't think of it. F apostrophe x. It's like. Is that what they do? Or do they do it? It doesn't say. Do they do f to the negative 1 power? No.
Last year we did.
They do. They call it f to the negative 1 power. We'll do what they do. Okay. Sometimes they'll call it f apostrophe. Sometimes they'll do f to the negative 1 power. So this doesn't necessarily mean to the negative 1 power. It really means inverse, f inverse of x. Okay. So sometimes they'll do an apostrophe. Sometimes they'll do a minus 1. Whatever. Okay. We'll do the same notation that they do. Okay. Good. All right, let's practice that. So, find g of x. So they're not wanting us to call it f inverse of x, right? They're wanting us to call it g of x. So, in our fourth step, instead of switching it to f inverse, we're going to call it g of x. But they want us to find the inverse of this guy. So, step number 1. F of x, we switch it to y. So, y equals 3x minus 2. I just rename it, okay? Now, a lot of people skip step number 1 and go straight to step number 2 because they, in their head, can switch the x and the y around and change the f of x to y at the same time, right? Okay. So if we switch the x and the y around, this will be x equals 3y minus 2. Yeah? Okay. Step number 3 is where we solve. Step number 3 is the longest of the 4 steps. Okay. Everything else you're just renaming. Okay. So step number 3, what are you going to do first? Add the 2. Okay. So we have x plus 2 equals 3y, but we're not quite done yet. Divide by 3, okay? Divide by 3. So I can write that as y equals x plus 2 divided by 3, or just keep in mind that also looks like y equals x over 3 plus 2 over 3. Does that make sense?
Oh.
You can call it 1/3 x as well, or y equals 1/3 x plus 2/3, okay? All of those 3 things mean the same thing. Does that make sense?
That just seems like a
Whichever
whole
way
lot
you
of
want to
extra
write it.
work.
Now, it's less work if you write it in this form, but if I were to graph this thing, this is a linear function, which one's the easiest one to graph? Y equals 1/3 x plus 2/3, right? This is where you start at 2/3 and you go up 1 over 3, right? So if you're going to graph it, I would suggest going all the way out to the third form that we wrote. Does that make sense? Okay. Now, we want to call this not y, but we want to call this guy g of x. So I'm just going to call him g of x. Okay. If they don't tell you what you want to name it f inverse of x, right? Okay. But they said we're going to call it g of x. G of x is the inverse of f of x. So that's what we're going to name it. Does that make sense? Okay. You remember this kind of somewhat from algebra 2, maybe? Yeah?
So is that the fourth step? Yes.
Yes. That is the fourth and final step. Okay? Yeah, you can write number 4 next to that. We renamed him. Okay? Good? All right, example 3, finding the inverse of that guy. Do I want to do that?
Well, are we going to have it on our homework?
Yeah, it's kind of gross though. Okay, so I'll show you why this is gross. Here we go. Step number 1, rename it. Y equals x squared plus 4x. Okay. Step number 2, x equals y squared plus 4y. Oh, my 4's and my y's look kind of the same. Step number 3, we want to get y by itself, right? How do I get y by itself when there's 2 y's? I have a y squared plus a 4y.
Square root. Square root.
Nah, I can't take the square root.
Oh, no.
So, we could try to FOIL it.
Divide by y. just divide by y. That's totally legal. Then
Divide
you
by
have
y?
plus 4.
No, we can't divide by y because it gets rid of it.
Why?
So you know what they're going to have you do? This is going to be really gross. This is going to be really gross. Subtract the x to the other side. Okay, so we have 0 equals, I told you this is going to be gross. I told you this was going to be gross. I warned you. Okay, minus x. Okay. They are going to have you, if we want to leave it as an equation, if we were solving for y, we would factor a y out. I would pull a y out and set y equal to 0 and y plus 4 equal to 0, right? But it's not equal to 0, it's equal to x, and I can't do that. So what I have to do is, now that he's in this form, I have to do the quadratic formula. Okay? But grossness, let's talk about the a, b, and c for our quadratic formula. Okay? So what is a? A is 1. Okay, it's the number in front of the y squared. So a is 1. B is 4. What's c? Negative x.
Why is it not?
Okay? It's not a number because we're putting everything in terms of y, right? So if everything is in terms of y, then x is considered to be a number. Does that make sense?
Why can't x be a number?
What's that?
She just said it.
Why can't what?
Why can't x be a number?
Why isn't c a negative 1?
Why? Why isn't it x? She just.
So the c term is always this term right here. So c is equal to negative x.
But she
that
wants
make
to know
sense?
why it's not negative 1.
Why it's not negative 1? Because everything's in terms of y. So if there was a y variable there, then it would just be negative 1. But since everything's in terms of y, x is just a number. It's the weirdest thing. It's the weirdest thing. So when we do the quadratic formula, okay, do you want me to write out the quadratic formula? Do you guys have it memorized? Do we write it out? Caleb's like, let's write it out. No? Okay, negative b would be negative 4 plus minus square root. B squared comes next. What's b squared? 4 squared, which is 16 minus 4 times a is 1 times c is negative x. I'm running out of room. Okay, so actually it would be positive 4x. Okay, we'll get to that. Just wait a second. And all over 2a, which is 1. Okay, so I have negative 4 plus and minus the square root of 16 plus 4x, and there's nothing I can do to combine that, all over 2. Okay? And there's one thing that I'm missing. What equals that?
0. Why?
Y, right? We solved for y, right? Y equals that. And this is an equation because it still has x in there, right? We still have x, our number, in there, okay? And then the last thing that we're going to do is we're going to switch this to f inverse of x, or did they tell us to call it something else? Find the inverse. So they didn't tell us what to name it, so we're just going to call it f inverse of x. This is step number 4. And it's this gross, ugly, nasty stuff. Okay? And we'll just leave it like that. Technically, you could take a 4 out of the square root, but we're just going to leave it. Okay? That is my new equation. Okay? Now, we said that, let's look at the original equation. He was a quadratic function. Okay? Quadratic function like x squared. What was the inverse of x squared? Square root, right? But since it's not just x squared, since it has that 4x in there, it's not just the square root, right? But it has a square root involved in it, yeah? Does that make sense? So, he's kind of gross. Okay, good? Kelsey, do you want me to stop videotaping? I'm videotaping for you. You want me to keep going? Okay. All right. So, all right. The y values do not repeat. Note if a relation is a function, the x values do not repeat. Okay. So we talked about this before. It is a function if x's do not repeat, yeah? Okay, if x's do not repeat. All right, so if I am talking about this parabola, like y equals x squared, is that function, or is that guy a function? If I have y equals x squared, I'm making this up. If I have y equals x squared, that's the graph of him. Is he a function or not a function? How do you tell whether he's a function? The vertical line test, right? Okay. All right, so I'm going to get rid of that. Vertical line test says, yes, this is a function. Okay? Now, does x squared have an inverse function. Okay? We're going to talk about this. We said that x squared and the square root of x are inverses of each other. But is that inverse a function or is it just a relation? Okay? When we graph these two guys, this is my original function. Okay? The x squared, okay? If I find his inverse, it becomes this. Does this guy pass the vertical line test? No. So his inverse, even though he has an inverse relation, his inverse is not a function. So I'm going to put no, just an inverse relation. Okay? You guys know the difference between relation and function? Everything is a relation. Every equation, everything is related somehow. Everything is a relation. But only things that the x's don't repeat are functions. Okay? Now, here is how you can cheat. Okay? I don't have to think about what the inverse function looks like. What I can do is the horizontal line test. Okay? Normally we're doing the vertical line test. I do the vertical line test on this guy to determine whether he is a function or not. If I want to know if his inverse is a function, I go across this way. I do the horizontal line test. So this guy passes the vertical line test, but if I do horizontal lines, does it pass? No, that means his relation or his inverse is not a function. Does that make sense?
Yeah.
So to figure out whether his relation or his inverse is a function, you do the horizontal line test. Okay? I don't even have to think about the graph of the inverse. I just look at the graph of the original. Yeah? Okay? All right, so using the horizontal line test, graph each function below and determine whether the function is one-to-one. If so, graph its inverse function. Okay, so I don't know what the graph of these guys look like. I know that x to the 5th power goes like this. Should we plug it into our calculator and see? Okay. Let's plug him in and see.
That's gonna be so.
What's that?
My notes don't have a back.
I know you don't. Here you go. We had a problem, so. Okay, let's plug him in. Actually, you know what? Here's what I'm going to do. You guys all know how to graph this on your thing, right?
Yeah.
So that we don't slow my computer down too much, I'm going to graph it on Desmos. How about that? Okay? You guys know how to graph this on your graphing calculator. That's what I would do. But I'm going to graph it on Desmos so it doesn't slow me down so much. Woo. Okay. I need functions. Why? Where's my thing? There we go. Y equals. Okay. Would somebody want to read it to me? What was that function at the top?
7x to the 5th
7x to the 5th
plus 3x
plus 3x
to the 4th
to the 4th
minus 2x to the 3rd
minus 2x to the 3rd. Okay.
plus 2x
Plus 2x
plus 1.
plus 1. Okay. So here is my function. Yeah, do you see him? Is this guy a function? He is a function himself, yes? Is his inverse a function?
Yes.
How do I know his inverse is a function? Horizontal line test, okay? Or you can tilt your head to the side and do the vertical line test, right? Okay, so let's go back. This guy, if you want just to like make a little note, he looked like this, like a skinny guy, okay? So yes, his inverse is a function. Okay, his inverse is a function. Yes, that was part A. Part B. Can I go back to Desmos?
Yeah.
X cubed minus 3x minus 1. Okay, here we go. Desmos. Y equals x cubed minus 3x minus 1. Is he a function? Is he a function?
No.
Yes.
He is a function himself.
But
Vertical line test passes. He is a function himself. Is his inverse a function? No, because if I do the vertical line test, like in the middle, I can't draw on here. If I do the vertical line test in the middle, he does not pass. Or excuse me, the horizontal line test in the middle. So B, I'm going to do B in a different color. This is what the graph of B looked like. He did one of these, okay? So he himself is a function, but if I do the horizontal line test there, he's not going to pass. So B, no. His inverse is not a function. Okay, my handwriting is getting sloppier because I can't rest my hand on my screen. No, his inverse is not a function. Now, he does have an inverse. It's just a relation. It is not a function. Does that make sense? Okay. All right, so C. Let's go to C. 1 minus 0.2 x cubed. This goes actually a lot faster. 1 minus 0.2 x cubed. Okay. Let me zoom out, make sure I can see all bubbles. Is he a function? Yes. Is his inverse a function? Yes. Yes, yes. If I go horizontally, it does not flatten out there in the middle, even though it looks like it does. Okay. If I zoom really, really far in, you'll see that like he doesn't actually flatten out in the middle. Well, it kind of does look like he flattens out. But anyway, if I keep zooming in, whatever, he does not actually go entirely horizontal. So he is not doubling up horizontally, is what I'm saying. So he does pass. He looks, I don't know, like this. I think he went the other way, but it doesn't matter. Anyway, he passes the horizontal line test, so yes. His inverse is a function. Okay, are we clear on that? That was C?
Yeah.
Clear? Easy?
Easy done.
Good stuff? All right. Where are we on time? Good. Okay. Blah, 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 blah. Okay. All right. Example 5. Find an interval upon which f of x equals x squared. Let me pull this down here. She doesn't want me to get done. All right. All right. Find an interval upon which f of x equals x squared is 1 to 1 and find f inverse on that interval. Okay. So we want to look at f of x equals x squared. I'm going to graph the original f of x equals x squared. Here he is. Okay. And if I do his inverse, we've already talked about him already. His inverse looks like this. Okay. Is his inverse a function? No. Is there a way that I could restrict the domain so that his inverse is a function?
No.
Like I could say, let's just look at the top part of this graph, right? How can I say, I don't want you to look at this bottom part. I want you to get rid of that. How can I say we're only going to look at the top part of that graph?
Plus positive.
Y has to be greater than or equal to 0. That's how we're going to restrict this guy. Okay? I'm only wanting you to look at, I'm blinding you to the rest of it. I'm only wanting you to look at the top half of the graph, which are all of the y's that are greater than or equal to 0. Does that make sense?
Yeah.
Okay? That will only let you see this top part here, and it will not let you see the bottom part. So in other words, I am only allowing you to see the square root of x and not the negative square root of x. Does that make sense? I'm not allowing you to see the bottom part of it. But when it says find an interval on which that is 1 to 1, it will only work if the y coordinates are greater than or equal to 0. Does that make sense? Yeah, kind of. You won't have too many of those on your homework assignment, I hope. But anyway, if I restrict the y coordinates so you're only looking at the top half of that graph, then he is a function, right? If I get rid of this bottom part, now does he pass the vertical line test? Sure, he's only going to touch once, right? So as long as we're only looking at the top half of the graph, or y's that are greater than 0, then he is a function. Yeah? Okay. All right. Last thing, what happens is, we've done compositions before. Okay? Compositions are like f composed of g of x, right? Which I wrote it with parentheses, right? And we don't like that. Fog and Goff, those ones, okay? If we're talking about composition functions, okay? And we take functions and stick them inside of one another, okay? I'm going to give you an easier example before we do this one down here. Let's say I have f of x is 4x and g of x is 1/4 x, okay? Suppose I want to see if those two things are inverses of each other, okay? So what I could do is I could just start with one of them, do the 4 steps, and see if it turns into the other one. Or I could do this. I could do f composed of g of x, and then I could do g composed of f of x. Okay, and that's what we're going to do here. So if I do f composed of g of x, this means I'm sticking g of x inside of f of x. Yeah? Sticking g of x inside of f of x. Okay, f of x was originally 4x. Yeah? 4x. But now I'm putting this 1/4 into that. Right? So 4 times 1/4 x. Yeah? What is 4 times 1/4 x? What's 4 times 1/4? 1. So it's just 1x, or just x, right? That's what he simplifies to be. Okay? Now let's do the opposite way. Let's say I'm taking f of x and I'm sticking that into the g of x function. Okay, so I'm taking this guy and I'm shoving him in here. So he was 1/4 x, but now I'm putting 4x in his spot. What does that come out to be? 1x, right? 1x. Okay? Now, when that happens, when it simplifies to be not the same thing, but when it simplifies to both be x's, they are inverses of each other. Okay? So that's a way of checking to see if you did the inverse right. Stick one inside of the other and vice versa. And if it comes out to be x, then it is you did the inverse correctly. Okay? So that's what this rule up here says, that if I take f inverse and I plug f of x inside of it, if I plug f of x inside of the inverse, it comes out to be x. If I take f inverse and plug it into f, it comes out to be x. Now, do you know why it comes out to be x? That's what people don't know. Okay? Why does it come out to be x each time? Okay, when we graphed those inverse functions, I'm going to make you dizzy. Okay, when I graph those inverse functions, what's the name of this line called that they are reflected across? Y equals x. Ah, right? Nobody did that? Ah, that's why. They are inverses of each other because they're reflected across the line y equals x. So when you stick one inside of the other, they flatten out to be x, right? Okay, that's what he looks like. All right, let's go down to the very, very, very bottom example. Use composition to verify that f and g are inverses of each other. Okay, f composed of g of x, and then g composed of f of x. Okay? All right. Blah, blah, blah. First one, I'm taking g of x and I'm plugging it into f of x. Okay? What I do, since these are ugly, what I do is I always start with the outside function. I think I did this in the video. The last video, maybe we did. I start with the outside function, f of x. Okay, f of x was 5 over 2x minus 4. That's what f of x was. But instead of the x, I put a parenthesis. Yeah? Does that make sense? Okay, you write out the outside function, but in place of the x, you put a parenthesis. Okay? In that parenthesis, I'm going to say 4x plus 5 all over 2x. Okay? Minus 4, yep. Okay?
That's disgusting.
That is gross. That is so disgusting. Okay, now what? You could distribute the 2. Really, this is like 2 over 1. Okay? And the really nice thing is this 2 will cancel with this 2. Yeah? Right? So it is, okay, on the top we have 5. Okay, we're just going to have him chill out. 4x plus 5 over x, and then I have minus 4. Okay? Now, watch this very carefully. This is the hardest step. Okay? This guy is 4 over 1, and what I want to be able to do is combine these two things. But this one has a denominator of x, and this has a denominator of 1, right? So what's my common denominator going to be? 1x. So what I'm going to do is I'm going to multiply this guy by x on the bottom, which means I have to multiply him on the top. Okay? So do you agree that negative 4x over x is the same thing as negative 4? Right? Those x's would cancel out, but I'm adding them on there so I can put them all together. Does that make sense? Okay, so on the bottom part now I have 5 over, and I can put them all under one roof. I have 4x plus 5 minus 4x all over x. Yeah?
Can't you cross out the 4x?
Yes, yep. Are we seeing it now? Kinda? Okay. 4x minus 4x will go away. Okay, we're getting closer. So, I'll go slow. Okay. 5 divided by 5 over x. That's all we have now. Okay, now what do we do?
Multiply.
I'm
X.
dividing by 5 over x. I'm dividing by a fraction, so I can
You can multiply it to the top.
I can multiply by the reciprocal. I can multiply him to the top. So I keep flip. I multiply by x over 5. So this is 5 over 1 times x over 5. What happens?
Cross out. It's just 1.
The 5's cancel, so it is just x.
What the heck?
Okay, now we gotta do the other side. But I think the other side is easier. Is the other side easier? Oh my gosh, this is craziness. Okay, that's really, oh man. Okay, we'll see how ugly it is first. So now we're taking f of x and we're plugging it into g of x to start with, okay? So g is my outside function. So I have 4x plus 5 over 2x, right? But in place of the x's, I'm putting the other stuff, okay? 5 over 2x minus 4. 5 over 2x minus 4. Wow. And we do all of our simplifying and everything, and it all comes out to be
X.
Oh, beautiful. You're so smart. There you go. It all comes out to be x. I'm going to cheat because I don't want to do all that. But anyway, so it all comes out to be x. So what does that mean?
Yes. So
Yes. What does that mean?
function.
Nope.
They're inverse.
F and G are inverse functions. Boom. Done. We win.
We win.
We win. Okay, those were inverses. Wonderful. You will not have anything that ugly on a test, I promise. I think. I can't promise you that. I don't think you have anything that ugly. I don't think. If you do, save it and we'll do it in class together. Okay?
Okay.
How about that? All right?
Fair.
Yeah, skip it. Okay, deal? All right, there you go. Woo! Okay, homework. Again, the top right here. It's either up there or up on the board. How was that, Ellie and TJ? Are you sleeping yet?
Not quite. It was fine.
Not quite? Okay.